Welcome. In this video, I will discuss function overloading in C++. So, the first thing we need to talk about is function signatures. Recall that we have function prototypes, and those look just like this, where we have some function, and we're going to have a return type for that function right here, and we'll have an identifier, what we are calling that function. It's the name of the function. And then inside we have a formal parameter list. Well, when we create this function here, the compiler, it is going to read this function, and it is going to create a function signature. And this function signature is going to be used by the compiler. So when it sees the calls to the functions later on in your program, it will know that those are valid function calls. So what is a function signature exactly? Well, a function signature is something that holds a little bit of information about a function. It holds the identifier of the function, so whatever you are calling your function, whatever you're naming it, and it holds the formal parameter list types, and inherently it holds the count because it holds the types. It holds a list of the types. So you have some list of formal parameters right here, and all of those formal parameters have types. Well, it's going to carry a list of all the types that those formal parameters are, what order they should be in, and inherently you'll have the count as well. What does it not include, though? It does not include the return type of the function. That is very important that it does not include the return type of the function. And it does not include the names of the formal parameter list parameters. So this is what a function signature would look like. It would have your identifier and then some formal parameter type list. And this type list is just a list of all the types of the formal parameters. So that's all good and dandy, but by example is much better. So here we have a function header, func1, which has an integer a and an integer b. And its function signature looks just like this over here. It is the name of the function, the identifier, func1, and then we have an int and an int. We have a list right here, and it goes in order int. You can't tell really the order right now since there's two ints, but we can tell in a later example. So if we come down to example 2, you see we have void func2 string s, and that will be turned into func2, and we have a list that just contains string because there is only one parameter string. So inherently, we know that there is only there's one parameter, and that parameter is a string. And then here in the third case, we have a character returning function called func3. It takes in two strings and an integer, and that gets transformed into func3 string int. And here you can see that the order does matter. The order of the list is string int, so that the compiler knows so that it needs to go string int. The compiler will then also know that it needs three parameters when this function is called as well. Now, let's talk a little bit about different formal parameter lists. And what does it mean for two functions to have different formal parameter lists? Well, that means that they have a different number of formal parameters, or that the number of formal parameters is the same, but the data types are different of the formal parameters, or the data types can be the same, but there needs to be some sort of rearrangement between those data types. And we will see that in some examples on the next slide. One thing to note is when we are telling if two formal parameter lists are different, the identifiers are not taken into account at all. They do not matter. It is all about the data types. And as we will see in later slides, to overload functions, two functions must have different formal parameter lists. And that should be two or more functions, really, because you can overload a function with as many overloads as you would like, as we will see in examples later on in this video. So here is some examples of some different formal parameter lists that functions can have. These are not all of them. Obviously, there's an infinite mixture of formal parameter lists that functions can take. But here is just a couple examples. So we have this f1, and its formal parameter list is int. Whoopsies. We have f2, which its formal parameter list is int and double. We have f3, which has a formal parameter list of int and int, as you can see here. f4 has a formal parameter list of int char double. And function 5 has a formal parameter list char int double. All of these have different formal parameter lists. Obviously, this one has a different formal parameter list than all these because it only has one. It has a different count than all four of these. These two have different formal parameter lists than the first one and 4 and 5 because they have a different count, but inside of them, they have a different formal parameter list because they have a different second formal parameter list type. This one has a double, this one has an int. And then down below here, they have 4 and 5, they have different formal parameter lists because yes, they have the same formal parameter list data types, but those data types are rearranged right here. This int and this char is flipped, and then that's fine that this double is in the same place. You just couldn't have any combination where they would be the same. So you could flip those, you could have flipped these, you could have flipped that one and that one, any flip that would make them different. But if we come down to here, 6 and 7, we have this f6, which takes an integer and a double, and this f7, which takes an integer and a double. And when we look at their formal parameter list, it doesn't matter that the names are different because the names don't come into account when we are checking if formal parameter lists are different. So even it just boils down to that they have the same formal parameter list because they have the same data types in their formal parameter list, the same length of formal parameter lists, and those data types are in the same order. Now, let's talk about function overloading, where we take all of this and put it together in an actual practical thing that we can do in our programs. So, function overloading is when we create several functions that have the same name, the same identifier, but different parameters. So, two functions are different if they have either different names or different formal parameter lists. So, two functions can have the same formal parameter lists, but they have to have different names if you want it to work. But when we're function overloading, this first rule is not going to be satisfiable because they won't have different names. They'll have the same names. So it's going to have to follow the second rule where we have different formal parameter lists for our functions. So we're going to have a bunch of functions. They're going to have the same identifiers, and the way that they're going to be told differently be told apart by the compiler is that they have different formal parameter lists. And one thing to note is that changing the return type is not a valid way to overload a function because the return type is not included in the function signature. So if you change the return type, the compiler will have no clue still that two functions are different, so it will just not work, as we'll see in the example here in a second. So here we have some examples of valid and invalid overloads to a function. As you can see, all of these functions have the same exact name function. The difference with them all is they have different formal parameter lists. Number 1 here has no formal parameters. Number 2 here has 1 formal parameter. Number 3 has 2 formal parameters, an int and a double. Number 4 has an int and a double, and which is 2 formal parameters as well. But that int and that double are flipped from this example 3 here, so that is still okay. And then in number 5, it is the only one with 3 formal parameters in its list, so we know that the overload is okay. But when we come down here to number 6, this is not a valid overload to the function, because although we're changing this data type over here, the return data type, we have a copy of the formal parameter list from example number 1 up here. So the compiler will not be able to tell the difference between example 6 and example 1 because they do not have different formal parameter lists. And since the function signature does not include this return type right here, it doesn't matter that we changed it. So this is not a valid overload to the function. Now, let's take a look at function overloading from a programming example. Here we have a function that we are going to overload. You can tell that we are overloading this function because we have the same identifier for all of the functions. And how the compiler is telling the difference between these functions is, again, the formal parameter lists of each of them are different. And you can see over here in the comment the signature that is created by the compiler for each of the functions that is going to be created. And remember, these return types do not matter to the compiler, so these return types could have been anything. Just for this example, they are all void, but they could be different. So if we come down here, we have some integers, doubles, float, character, and a string that we are going to print using our overloaded function. And if you can see here, we have the overloaded function, which has the same identifier for all of the function calls, but there is different data types being passed to each of those function calls. As you can see up here, that C is character, S is string, F is float, D is double, I is integer. So the compiler, again, is going and differentiating these function calls by looking at these signatures, and then it can go, okay, cool. I'm getting passed an integer in this function call, so I'm going to need to use this print, which gets passed an integer. Same thing for this double function call right here. It knows from this signature right here, from this function prototype, that when it gets past the double, it needs to call this function call, or this function definition. And these are all defined down here, so it's going to actually be sending it to these function definitions down here. And all these function definitions simply do is output a nice little message, what the data type is, integer, double, float, or character, or string, and then outputs the data to the screen. So it just displays the data to the screen. And if we come over here and open up a terminal, if we compile this, once the terminal loads with G++ and the name of the program, we get a.out, which we can run with /a.out. And you see we get proper function calls, or proper data types for each function call. The first function call here is our integer call, and you can see we get the integer function version of our function called, because as you can see, integer gets printed out in this label, and it is an integer that gets printed out. There's no decimal place after it. But for our double value, we get a call to the double function. And note, look, we get a different call when we pass a float value. If you come up here, we have differentiated a double and a float different. So they actually do, even though they're kind of the same, they are still different data types. But, well, they're not kind of the same. Obviously, one is of single precision, one's double precision. But the compiler obviously can differentiate between that. And then down here, we get the character output from this function call. And finally, we get the string output from this function call. And that is all I have for you for this video. Thank you so much for watching, and we'll see you in the next.